Hey guys, it's Miss Landry, and today we're going to learn about science as a process. You've probably heard it called the scientific method. I don't really like calling it that because the method implies like it's a straight line, like you do this, then you do this, then you do this, then you do this, and that's not at all how science goes. You do have some guided notes for this, so make sure you have those on hand so you can write them as you go. This is kind of what you probably heard the scientific method one was: ask a question, get a hypothesis, perform an experiment, collect data, and draw conclusions. It is way more complex than that. So let's jump right in. So on your guided notes and also on the Edpuzzle, I would like you to draw or type two things that you already know about the scientific method. Okay, so you've been exposed to it before, so tell me two things you know about it. Pause the video and go ahead and do that. Okay, so I will take a look at those. It kind of primes your brain to start thinking about it. The one thing I want you to know about the scientific process is that it is not linear, okay? Meaning it doesn't go in prescribed steps. I think this right here is probably a better vision of what the scientific process is. And if you notice, the arrows go around all over the place. I might even have arrows here. I could have arrows going here. I could have it going here. Okay, so the arrows are all over the place. It's more like a spider web, okay? So the first thing that you're gonna do though, and you do this without even thinking about it really, is you're gonna make observations. Okay, you do this all the time, and kids are great at this, right? So the first thing, let's say I'm at Kent and I say, wow, there's a lot of geese on Kent's campus. That's an observation. Now from my observations, I can come up with a question. I wonder, like, are these the same geese that were here last year? Are these different geese? So I come up with a question that I'm going to test. Do geese stay year-round on Kent's campus? That's my question. Okay, so right now we're right here. We've already made observations. We're thinking of a question. Now I'm going to form a hypothesis, and we'll go over how to do that in some pretty good detail. If it's going to be an if-then statement. So if geese live on Kent campus year-round, then the numbers won't change for a year, except for births and deaths. So that's pretty easy to measure, right? So I'm going to make a prediction. Predictions are important, right? What do I think the numbers will look like? So if I don't think that the geese move, then I think the numbers are going to stay pretty steady. Oops, sorry, let me clear this off. So let's take a look at this. So right now we are at predictions, right? So we're kind of like right here. So the next thing I'm going to do is, I don't know why this isn't working. Sorry, bear with me. There we go. So next I'm going to test my hypothesis. So what you need to do is you actually need to design an experiment and collect data. And we're going to be doing a lot of that. So I think you guys will, I think you guys will like it. Once you have your data, you have to analyze the data and decide, did it support my hypothesis or did it not support it? So for example, I might look at the data, and if all the geese numbers were the same, then that would support my data. But if there were less geese in the winter months, that would not support my hypothesis, right? So in that case, I have to figure out what I think happened. One of the things that's really important, and I want to make sure everybody understands this, so pay close attention here. We don't prove anything in biology, okay? If I see you use the word prove, I'm going to call you out on it. We don't prove anything. What we do is we support hypotheses, or we find data that doesn't support hypotheses, okay? So please don't use the word prove. Like, just the fact that I counted geese does not prove that the geese stay there all year. It supports the theory, but it doesn't prove it, okay? So once you have a theory, then you have to, let me move me, you have to develop why, the theory of why. So it's kind of the because, like, why do I think the geese are staying there? Well, I think it's because they have everything they need, so there's no need to migrate for the winter. Okay, so that's an example of the process. And I think you guys will find it's actually pretty fun. Okay, what happens when your data is incorrect? Does that mean that you have failed as a scientist? Absolutely not. A lot of science is going to go wrong, okay? And it's okay to be wrong. It just means you have to redesign or rethink or go back to step one, and that's totally okay. There's a link. Oops, sorry. Let me go back. Here we go. There's a link right here to a really good video about some scientists that were wrong, and they were astrophysicists, and it's all about like their process, and it's really good. Carl Sagan is another one of my favorite scientists, and he said there are many hypotheses in science which are wrong, and that's perfectly all right. It's the aperture to finding out what's right. Like you have to be wrong in order to get to the right. Okay. As a matter of fact, being wrong still moves our knowledge forward. So don't feel like being wrong is in any way a bad thing, because it is not. Okay. I want you to pause the video and summarize what you've just learned about the process of science on your guided notes, and then come on back. Okay, so we're going to start with observations and kind of break it down. We're only going to go through observations today, and then we're going to move on to hypotheses and stuff on the next video. So let's start with observations, okay? They are factual, meaning they're facts. They can't be denied. It doesn't require prior knowledge. It takes practice to know the difference between an observation and an inference, and it's not always visual, right? So humans are very visual, but we also get observations through smell, touch. Please don't taste in the lab, but taste is one. There's lots of different ways that we get observations. So take a moment, and on Canvas as well as on your guided notes, I want you to make 3 observations about this image right here. Okay, so observations that I could make on this one, I could say, well, there's this animal is orange and black. I could say this child is wearing a hat. The tiger is carrying a flag. The child is holding a piece of paper of some kind. Those are the types of factual observations, okay? Now that is very different from inferences. With inferences, what you do is you make assumptions about what you're observing based on previous knowledge, some experience, a conclusion, or an opinion about an observation, right? So I would look at this picture, and I want you to take a second and think to yourself, what kind of inferences could you make about this picture? Go pause the video, write down some inferences, and come on back. Okay, so inferences I could make about this are that, well, they look like they're going out to find buried treasure or something, right? They're on an adventure, so I'm trying to draw a treasure chest, which is coming out terrible. They look happy because they're both smiling. That's an inference. They're outside. That's an inference based on the grass that I see. Okay, so those are inferences. They're not actual facts. These are things that you're saying, wow, like I have seen people in the past carry a flag and a treasure map, and they're going on an adventure. So inferences are very different from observations. So pause the video and make observations and inferences about the image on your guided notes. Okay, welcome back. Hopefully you get the difference between observation and inference. We're going to pause here. Go ahead and do some of the practice on there, and then come on back for the second video when you are ready. Thanks, guys.